Hey, hey. Okay, so now we're going to look at noble gas configurations. All right, we're getting there. Let's see, I'm going to share my screen here. Share. Go like this, like this. Oops. There we go. Great. Okay. So we're going to label this. Let me get my pencil. I don't want green. It's maybe pretty purple. Let's call this noble gas configuration, right? It is an abbreviated form. An abbreviated. Okay, I'll turn my hair down. An abbreviated form of electron configurations. All right. Please make sure that you are watching my videos, pretty much configurations in their entirety, because you're going to hear me say things that are important for you to know. All right. Now, we are very aware that these here are our noble gases. I did not state in the last video, but helium does not have 8 valence electrons. He only has 2. You guys should be fully aware of that. Okay, let's put me down here. Right, he's got 2 valence. He's got a full outer shell. That's why he's a noble gas. Neon is going to end in 2s2, 2p6. We know that argon ends in 3s2, 3p6. Krypton's going to end in 4s2, 4p6. Xenon's going to end in 5s2, 5p6. And radon is going to end in 6s2, 6p6, right? So their outer valence shell, their valence shell is completely filled, right? Something about that, and his is completely filled. There's no 1p, right? There is no 1p here. So he's got the 2 valence, and all of the rest of these have the 8 valence, right? You're aware of that. And there's something very stable about this configuration, you know, it's been observed over and over and over. So why is 8 the magic number? Don't know, but it is. So all of these have a completely filled outer energy level. So we can utilize that fact to do an abbreviated version of electron configurations, because we know that after after 2p6, we come right here. After 3p6, we go right there. After 4p6, we start over. After 6p6, we start over, right? So we can utilize that fact. Let's clear this up. It's very messy at this point. And let's pick an element such as, let's see, let's do chromium, right? And let's write the noble gas configuration for chromium. Okay, well, what I'm going to do every single time is I'm going to go all the way over, and I'm going to go up 1, right? And I call that picking the preceding noble gas, right? So in order to get the preceding noble gas, I literally go to the element, read all the way over, and go up 1. And I'm going to take that noble gas, I'm going to put his symbol in brackets, all right? And what that's telling me is that chromium's first 18 electrons are configured just as argon's. So this right here takes the place of 1s2, 2s2, 2p6, 3s2, 3p6. Instead of writing all of this, which is argon's configuration, right? That is argon's electron configuration. Then it's got the full outer shell. Instead of writing all of this, I'm just going to write argon brackets. And then I know that after the 3p6, right, after this comes this right here, So I will end it with 4s2. Remember, after 4s comes 3d, and that's d 1, 2, 3, 4, right? I would have one empty energy level, orbital, I'm sorry, one empty orbital, 4 half-filled orbitals, and it would end in 3d4. To further your knowledge, we would have 2 valence electrons, right? And remember that when this element, was it chromium, forms an ion, these electrons here will be the first ones lost, these here, okay? Let's do one more. And if you got that, you're free to go. Don't envision I'm gonna say anything else. It's that simple, okay? Let's get blue here, and we can pick an element way down here. Let's do iodine. Let's go and pick iodine. So iodine, you know, you're like, oh my gosh, 53 electrons, really? No, we're gonna do it simplified. Let's go all the way over and up one. We'll pick krypton. Ooh, that was southern. We will pick krypton. Notice I'm then going to go over here. I'm going to start on this energy level. 1, 2, 3, 4, 5. 5s2. That takes me into the 4d. 4d10. Takes me to back to 5p. 1, 2, 3, 4, 5. 5p5. So that is my abbreviated version. Here are my 7 valence electrons, right, which we would predict based on our location, and we could continue on and on with that. All right, we see that he would have 1 half-filled orbital. He would want to gain that 1 electron to complete his outer shell, and we would expect iodine to have a -1 charge there. And guys, that's really it for electron configurations. Now, the abbreviated version, you've already put in the work to understand what's going on. Hopefully you understand the vocabulary. You cannot put argon as argon, okay? You can't do that. But what you can do is go neon, 3s2, 3p5, 3p6. All right, so don't be too lame and right, that's argon. That's not gonna work, okay? And we can go ahead and end that there. Oh, I gotta stop sharing. Okay, so I hope you guys are doing all right and hanging in there. Yeah, and yeah, it was a short one.